It turns out that consistency does matter, and here's how. Let's say that in program order, two cores do this. The first core is gonna store A1 into location D, and then store A1 into location F. Let's say that D and F are both 0 initially. The second core loads F into R1 and then loads D into R2. And let's say that now we print the registers R1 and R2. Note that we can have an out-of-order processor that reorders loads and stores. So in execution order, core 1 might still be doing the stores in the same order, but core 2 decides to reorder these two loads. Note that in a uniprocessor, reordering of loads, if this core is not writing to these locations, is perfectly okay. And in fact, even in a multiprocessor, most of the time it's okay. Now let's look at what's possible to get in R1 and R2 after this. In program order, these two loads on core 2 might execute before these two stores in core 1, so we can get R1 and R2 are 0. Here, these two loads in core 2, although they've been reordered, can still happen before core 1 gets to store, so we can get the same thing. These two loads can happen after the two stores, so we can get 1 in both registers here. In execution order, even if we reorder them, they can execute after the stores, so we can get 1 in both of them. In the program order, if these two happen like this, in between the two stores, we can get R1 when we load is still loading the 0 here, but R2 when we load is already loading the 1. The same thing can happen here. If these two loads are in between the stores, then R1 is gonna be 0 because it comes before this, and R2 is going to be 1 because it happens here. And now it gets interesting. We have seen that there are these three possibilities, so the question is, but can we get R1 to be 1 while R2 is 0? And in the program order, if we consider that, it's not possible. R1 being 1 means that when we read F, we read 1. That means that this load has to come after this store. If that happens, then this load has to be after this load too. So pretty much, if we execute this here, then this has to be here, and that means that if we read 1 from F, we will read 1 from D as well. So the R1 equals 1, R2 equals 0 cannot happen in program order. But here, R1 equals 1 means that this load needs to be here, and we can get a 0 in R2 if this load comes here. So if we put the stores in between the loads in the execution order like this, we will get a situation that was not possible in the original program order. So the programmer might have expected that this code can never result in this, but in an out-of-order processor execution on each core, it can. And note that this doesn't violate coherence at all. In all cases, a load and a store obeyed coherence. But do we really care about that? Sure, for some obscure orderings, this can happen. Do we really care? When does it really matter that this doesn't happen? And it does.